We have discussed torque and dipole in uniform electric field, but now we are going to discuss dipole placed in non-uniform electric field. Dipole placed in non-uniform electric field. Non-uniform electric field. In this situation, we have to discuss that what will be force and torque. Now see here, increasing electric field. डायरेक्शन है लेफ़्ट टू राइट, इलेक्ट्रिक फील्ड इंक्रीज कर रहा है और इसमें एक इलेक्ट्रिक डाइपोल प्लेस्ड है. ये इलेक्ट्रिक फील्ड का डायरेक्शन है ई माइनस क्यू चार्ज प्लस क्यू चार्ज. ए भी लिख लीजिए डाइपोल. अभी इंक्रीज कर रहा है फ्रॉम लेफ़्ट टू राइट. यहाँ देखो फोर्स क्यू ई बी, इलेक्ट्रिक फील्ड अलग अलग है तो ई बी और यहाँ क्यू ई ए. अब यहाँ पर इलेक्ट्रिक फील्ड देखिए इंक्रीजिंग डायरेक्शन है इलेक्ट्रिक फील्ड का, तो ई बी का वैल्यू ई ए से ग्रेटर होगा. ई बी विल बी ग्रेटर दैन ई ए, सो क्यू ई बी विल बी ग्रेटर दैन क्यू ई ए. दैट इज net force acts on dipole or acting on dipole in the direction of E, क्योंकि वही इंक्रीजिंग डायरेक्शन इलेक्ट्रिक फील्ड का है, इन द डायरेक्शन ऑफ E on the dipole. QEB greater than QEA, so net force act on dipole. Since dipole is parallel, so net torque will be 0. No torque acts on it. It depends upon situation. Parallel और anti-parallel के केस में कोई torque नहीं होगा. Now this is first condition we have taken. Second condition, electric field increases from right to left like this. Increasing electric field. Again, electric field directed from left to right, we can mark dipole minus q plus q ab. Here force q eb and here q ea. As we know that the value of ea here increasing direction of electric field, so ea will be more than eb. It means net force will act, net force acting opposite to the direction of electric field, opposite to the direction of electric field. Because this net torque again will be 0, because dipole is placed parallel to electric field, so no torque acts. It depends upon situation. यहाँ भी और यहाँ भी केवल फोर्स है, नेट फोर्स यहाँ भी है, लेकिन नेट टार्क दोनों कंडीशन में कोई टार्क नहीं है. तो सिचुएशन पर डिपेंड कर रहा है. अगर किसी एंगल पर होगा तो टार्क एक्ट करेगा, अदरवाइज नो टार्क एक्ट ऑन डाइपोल. बट नेट फोर्स विल एक्ट ऑन डाइपोल इन बोथ केसेस. नाउ नेक्स्ट टर्म which we have to discuss, electric lines of force or electric field lines. So write electric field lines or electric lines of force. We can write electric lines of force. So how can we define it? Electric lines of force, imaginary lines or imaginary curve, but electric field is real. These field lines are imaginary lines or curve. We can define as the path along which small positive charge would tend to move if it is free to do so in electric field. So electric field line can be defined as the path along which small positive charge tend to move inside electric field. We can mark like this. This is a path, curved path along which charge particle moves. If we draw tangent at any of its point, it represents direction of electric field at that point. This is curve, this point, tangent drawn. Curve along this positive charge would tend to move, and if we draw tangent at any point, it gives direction of electric field at that point. So this is definition of electric field lines or electric lines of force. Now we can draw electric field lines. So for point charge, suppose charge is positive charge plus q charge, so it will be radial, directed just away from charge like this. Starts from positive charge, ended to infinity तक जाएगा. For minus q charge, again it is drawn radial, represented by lines directed towards the charge. Direction determined according to direction of electric field. As you know, for minus negative charge, for positive charge direction away, negative charge towards. Now for 2 point charges. For 2 point charges, we can take it as an electric dipole also, plus q charge minus q charge. Electric field can be drawn like this, started from plus q charge, ended to minus q charge, like this. So for electric dipole also we can draw same way electric field lines. Two unlike charges, point charges are here. Now we can take two like charges, plus q and plus q. So electric field lines will be like this. Just moves away, and means has tendency to exert lateral pressure like this. At center electric field may be 0, so we can draw dotted line also. So this is electric field line for two like charges. Now for a charged conductor, suppose a conductor is positively charged, we can draw electric field lines like this. Direction just away, arrow is marked just away like this. It cannot cross the charge conductor because it cannot so drawn from surface only. It cannot be drawn inside the conductor because inside conductor electric field is 0, as we have discussed in case of charged ring. Now properties. First property is it forms, first property, continuous smooth curve, started from plus q charge, ended to infinity. So it forms this started, so we can say that it forms a smooth, continuous smooth curve. We can write this continuous smooth curve, it is first property. Second property, as we have drawn here, started from plus q charge, ended to minus q charge. So we can write starts from plus q charge, and ended to minus q charge. Does not form closed curve. देखिए कि ये इंपॉर्टेंट प्रॉपर्टी इसकी है, डज नॉट फॉर्म क्लोज्ड कर्व. जैसे प्लस क्यू से स्टार्ट हुआ, माइनस क्यू पर एंड हो गया. अगर माइनस क्यू से प्लस क्यू की ओर आता तो क्लोज्ड कर्व का फॉर्मेशन होता. ये क्लोज्ड कर्व का फॉर्मेशन नहीं करती हैं, जबकि मैग्नेटिक फील्ड लाइन क्लोज्ड कर्व का फॉर्मेशन करती हैं. तो ये एक डिफरेंस है मैग्नेटिक फील्ड लाइन और इलेक्ट्रिक फील्ड लाइन में. ये क्लोज्ड कर्व का फॉर्मेशन नहीं करेंगी, मैग्नेटिक फील्ड लाइन क्लोज्ड कर्व का फॉर्मेशन करेगी. नाउ थर्ड इंपॉर्टेंट प्रॉपर्टी, tangent तो आप लोग एक प्रॉपर्टी जानते हैं, टेंजेंट ड्रॉ करेंगे तो उस पॉइंट पर इलेक्ट्रिक फील्ड का डायरेक्शन रिप्रेजेंट होगा. बट थर्ड प्रॉपर्टी, नो टू इलेक्ट्रिक फील्ड लाइन्स can intersect each other at any point. No two electric field lines can intersect each other at any point. Now reason, suppose these two field lines intersect each other at this point, then at this common point two tangents are drawn. That is, it represents two directions of electric field at common point. At a point there must be only one direction. Two directions of any vector quantity is not possible. So what can we say? These two lines cannot intersect each other at any point. Now next property, it contract longitudinally. Longitudinal direction में contraction है. That's why two unlike charges attract each other. Here it has tendency to become far apart laterally. That's why two like charges repel each other. It has tendency to move away from each other. Now this will be movement away from each other in case of like charges. Now we can draw electric field lines in different region like this. Dense electric field lines and rarer electric field lines. Suppose this point is A, this point is B. Here electric field is EA and here electric field is EB. Now denser field line region, here electric field will be stronger, so EA will be greater than EB. Denser में stronger होगा और rarer में weaker electric field होगा. और पैरेलल इक्विडिस्टेंट लाइन अगर कहीं ड्रॉ की गई लाइक दिस, तो ये यूनिफॉर्म इलेक्ट्रिक फील्ड को रिप्रेजेंट करेंगे. यूनिफॉर्म इलेक्ट्रिक फील्ड. सो डेंसर में स्ट्रांगर, एरर में वीकर, और इक्विडिस्टेंट पैरेलल अगर है तो यूनिफॉर्म इलेक्ट्रिक फील्ड. दीज आर द प्रॉपर्टीज ऑफ इलेक्ट्रिक फील्ड लाइंस. यू शुड रिमेंबर ऑल दीज प्रॉपर्टीज. सबको एक बार देखिए और ड्रॉ करने का भी प्रयास करो. यू हैव टू ड्रॉ ऑल्सो दीज इलेक्ट्रिक फील्ड लाइंस. प्रॉपर्टीज. ठीक. ओके, थैंक्स.